Organic nomenclature, or naming in organic chemistry, is vastly different than naming learned in general chemistry. In general chemistry, it was a very simple model. You put the cation and the anion together, etc. It was something like sodium chloride or lead to nitrate, etc. With organic compounds, as you notice, we have large molecules. And those molecules cannot be named with a simple term. They have to include some information about where the substituents are, what substituents are there. So again, their location, what substituents are there, how long is the chain, what other substituents are around. So that's why organic nomenclature is different. Nevertheless, this is very systematic. This is set, by the way, by the IUPAC. The IUPAC stands for the International Union of Pure and Applied Chemists, or chemistry. And this is like the highest authority on chemistry, and including, of course, organic chemistry standards and naming. So let's start right away. We're going to focus mainly on organic compounds such as alkanes. We will mention alcohols and ethers toward the end. The parent name indicates the number of carbon atoms in the continuous carbon chain, or of course, if you have a ring, but we'll get to those later. So if you have 7, that would be heptane. If there are 6, that would be hexane. And of course, if you have an alkane, it ends with an E, A-N-E. So before we begin, you should commit to remembering all of these, the simple ones, from methane all the way to decane, 10 carbons. All of these should be memorized because you will see them all the time. And generally, there's no issue because you just work with them a lot. So if I have 7, that would be heptane. The suffix, which is at the end, indicates what functional group is present. So whether you have an alcohol or whether it's a simple alkane. So it would end with that suffix. And the prefix reveals the identity, what substituents, location, and number of substituents attached to the carbon chain, as I was talking here. So here's an example. 3, 4, comma 4 dash dimethyl heptane. And this is so you have 3, 4 dimethyl heptane. What does that tell me? It tells me I have 2 methyl groups. The 2 means 2 methyl groups. That di right here means I have 2 methyl substituents. Where are they? They're at 3 and 4, 1 each. And of course, the carbon chain would be heptane, and it's an alkane because it ends with an E, and of course here A and E. So that's what it is. Now let's start with the rules right away. The only way to learn this is to really remember the rules and to practice. There's no trick in this whatsoever. It's based on a system. There's no trick. Just remember that in science if it's based on a system. So let's begin. And I'm going to use the highlighter here as a way of helping you. It says, determine the number of carbons in the longest continuous carbon chain. Remember, we're naming acyclic alkanes now, and this is the parent hydrocarbon. So for alkanes, you want to start by determining the number of the carbons in the longest chain. So if we look at this, we see that this is the longest chain. And how many do we have? Got to start from, remember, baby steps, is that you have 1, 2, 3, 4, 5, 6, and 7. So you have 7 carbon, and what is that? 7 is heptane. We'll get to this, of course, next. Now, watch what the next rule says. It says that the longest continuous chain is not always a straight chain. Be careful. So in this case, rather than going all the way, you actually go down here. That would be the long chain. So again, that's your long chain, not continuing straight. So here's your long chain. So that would be 1, 2, 3, 4, 5, and 6. Yeah, 1, 2, 3, 4, 5, and 6. So that's 6 carbons, which is hexane. If you kept going the other way around, like continuing it this way, then that would be 1, 2, 3, 4, 5. 5 carbons is pentane, and that's not what we want. So be very careful. The next rule. The name of any substituent attached to the parent hydrocarbon is written before the name of the parent hydrocarbon. Basically, that's your prefix. The prefix is the biggest part, pretty much. Together with a number separated by a hyphen. As you see here, I had a hyphen to designate the carbon to which the substituent is attached. Give the substituent the lowest number possible. Very well. So after I said this was my longest chain, I should be counting from this way, from the right here, not the other way around. So if I'm going to number it the other way around, then you're going to see now 1, 2, 3, 4, 5, 6, and 7. Now here's the problem. Look where they meet. Counting from the right gives you 3 for the substituent. Counting from the left gives you 5. So this is the incorrect numbering. It has to be the lowest number, at least if you have one substituent. So therefore, we're going to erase this because we don't want too much noise here. Trust me, they're going to be messy enough. So you ask yourself, what substituent do I have? Well, this is just a line. That's basically a CH3 attached. So that's called a methyl. So your substituents are found in that sheet on your bright space, and I'm going to show it to you in a second, but let me complete this name right here. This would be called now 3. That's the location. Sometimes we call it the locant. What substituent is this? Methyl. And this is 7, so it's heptane. Now, notice how beautiful this is. This is telling you that you have a 7-membered chain here. Carbon chain, hydrocarbon chain. Here it is, 7. This is your substituent. And you have one of them, and it's at the 3rd carbon on heptane. That's what it means. Now, if you go to your Brightspace account and go to Materials and Resources right here, go down to Important Handouts, and that would be Substituent Names, and download a copy of this. It would open up this page right here. So you have the substituents. Now, let me warn you before you begin, that X doesn't mean a halogen. It means the X here is the attachment point. It's the attachment point where it has an attachment. So if you see a single line, that's a methyl. It's just one carbon. If you have two, if you have a line that extends where you have two carbons, that would be an ethyl. If you have three, that would be a propyl and a butyl, etc., and a pentyl, whatever it is. Of course, if you have a ring, that would be a cyclopropyl. We're going to get to these in a second. But then you have isopropyl, isobutyl, sec-butyl, tert-butyl. Don't worry about these down here because we won't use them in this semester. So what I need you to be able to know is from the beginning all the way down to tert-butyl down here. And then for the hydroxy, we won't work on as a substituent this semester. That's for next semester. But what I need you to know also is methoxy all the way down to iodo down here. So it's from methoxy. Okay, it's not letting me. Methoxy down to iodo. Now I will get to some of these later in the naming and talk about that there's also a systematic name for these. So, but I will accept these if you know them. Now, let's go back to our lecture. The next one is if you have more than one substituent attached to the parent hydrocarbon, the chain is numbered in the direction that will result in the lowest possible number in the name of the compound. So again, you need the lowest number possible. Write the substituents in alphabetical order, not numerical. So we always write things in alphabetical order no matter what numbers they have. So they can have a smaller number at the beginning, but they still use the alphabetical order as a principle here of writing the name. So let's actually highlight some. So it doesn't matter where you highlight from as long as you count in the right way. So here we go. This is your longest chain. And then I ask myself, what two groups do I have? Well, I have two substituents. I have this, and I have, of course, that here. Now, if you go to your sheet, well, we already did this one. This is called a methyl. So it starts with an M. And if you don't know this yet, we're going to show you. Br is called bromo. So they're always like this. Fluoro from fluorine, chloro, bromo, iodo. Bromo, bromo. Starts with a B. So B comes before the M. So that means that the numbering should be from the one that has the lowest, in an alphabetical order. So in this case, you would have to count from this way: 1, 2, 3, 4, 5, 6, and 7. If you counted the other way, 1, 2, 3, 4, 5, 6, and 7, you will get the wrong answer. Why? Because bromine starts with a B. So I'm going to write the names of both, but I know there's too much noise. That's why I don't like to write on both. So we will actually get back to this in a minute. So then the correct name would be this. 3-bromo. 3, and that's a bromo. Hyphen or dash. What's that 5? Methyl. And what is the carbon chain? We have 7. That's called heptane. It's all one word. So this is the correct. If you wrote the other way around, if you wrote 5-bromo, 3-methyl, heptane, that would be incorrect. All right, keep watching in the next video.